Induction to prove that 3 plus 3 times 5 plus 3 times 5 squared plus dot 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 plus 3 times 5n is equal to 3 times 5 in exponent n plus 1 minus 1 divided by 4. So let's prove it by induction. Let's go with the case 1. With the case 1 when n is equal with 1. And we have here, so we have these two numbers. 3 plus 3 times 5 is going to be equal whenever we have in this equation here, whenever we have a n, we are plugging with 1. 3 times 5 in exponent 1 plus 1 minus 1 divided by 4. And here we have 3 plus 3 times 5 is 15 plus 3 is 18. So we have 18 here is equal. And now let me try this one here. Now n is equal with 1, okay? So we have here 3 times n is 1. 1 plus 1 is 2. Is a 5 squared minus 1 divided by 4. And now this is 18 is equal. So we see here is a 3 times 5 squared is 25 minus 1 is 24 divided by 4. And this implies here is 18. And in other hand, 24 is divided by 4 is a 6. 6 times 3 is 18. So 18 is equal to 18. So it holds. For case 1 it holds. But let's see does it hold for the other cases. Let's see does it hold for the case when n we are substituting with the n plus 1. And now we are going to have this way. Okay, we have a hold this equation. So let me write this equation here. 3 plus 3 times 5 plus dot 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 plus 3 times 5 in n. I think is in n. Okay, in n. And plus 3 times 5 in n plus 1. And this is going to be equal with, whenever we have a n here, we are plugging n plus 1. And n plus 1 is going to be n plus 2. So everything is going to be the same. But let me extend this here. But this one here is going to be 3 times 5 n plus 2 minus 1 is divided by 4. And we want to prove is this going to hold. But in order for us to hold this one here, to hold this one, we are going to add in the original equation here 3 times 5 n plus 1 in both sides and this side here. And now let me take just this side here. I'm taking just this side to prove it is if I am adding. So if I am adding here 3 times 5 n plus 1 minus 1, if I am adding here divided by 4 plus if I am adding this 3 times 5 n plus 1, I want to see does it hold this equation here. Can I reach to this result or to the right side of the equation. So I am proving just at the right side. Okay, so everything here I can rewrite, but I am not rewriting everything because it's going to take a time. But to prove this, we are going to work just on the right side of the equation. And to work on the right sides here, so let me write here is a 4. So this one I'm going to rewrite everything. 5 times n plus 1 is minus 1, and the other hand I'm going here everything, this part, 3 times 5 in n plus 1, but I am multiplied everything by 4. Okay, this side here because I want to make the same denominator, times 4 here. And now I'm in this position, so let me extend, and this is going to be equal. Okay, so this is 3 times 5 n plus 1 minus 1, everything here is divided by 4. But now here I am going to distribute this one. Here is going to be 12 times 5 in exponent n plus 1, and here this one is divided by 4. But this one here I am going to distribute everything, and let's see what's going to happen. 3 times 5 n plus 1, okay, 3 times 5 n plus 1, and here is a minus 3. 3 times 1 is a minus 3. And I made the other part here what we have a plus 12 time 5n plus 1, and that's what I have here, divided by 4. But now, because this is the like term, this one here and this one here, I am adding 12 plus 3 is a 15. Okay, this is a 15, and time 5n plus 1 minus 3 is everything here is divided by 4. But this one here we can write in this form. We can write 4, and this one here we can factorize 3, everything here, and we can write 5 times 5 of 5 in exponentials plus 1. Okay, so let me go here, we are almost done. Time 5n plus 1, and is minus 1 here. So I factorize 3 in these two terms. And now this is a 5 is in 1. But because the base is the 5, I can add the exponents in this case here. And finally, I can write here is a 4, and I'm adding the exponent. Here is a 3 times 5 n plus 1 because I'm adding those exponents, and the base I'm writing according to the properties of the exponentials, and is minus 1 here. Now, and finally, let me do one extra step. I went too far. And finally, we can add this one here. We can add those exponents, and this is 3 times 5 n plus 2 minus 1 divided by 4. So this holds. We already proved that this side here is the same with what we were trying to prove, a little bit upper. So we are going a little bit up. So we were trying to prove this is a hold here. So this here we already proved. So this is the same, 3 times 5 n plus 2 minus 1 divided by 4. So this result is the same. It holds.